crayon, your binder. If you do not have your science notebook, if you do not have a pencil, you need to go get that now.
Again on the back. Practice. Fantastic. You are step level.
Sophie the Awesome looks like a very good book, but you do not need that book open on your lap right now. Make a mark where you're reading. Nothing that you have that looks like your science book, right? Do you have your science book anywhere? We're waiting for one Rocketeer and then we'll get started.
It looks like this. It's the start of a new paragraph. Stop right there. So you're
Ready? Settle?
okay. So if you're not sure what stopping, kind of at the top.
Rocketeers, my name is Dr. Scott, and I am really excited about you today because we need to rotate. And not only are you learning to be really amazing readers, but you're also learning to be really amazing scientists. And so that's the sort of student I was looking for. I was looking for students who want to get really, really good at reading, and students who want to be really good at thinking about the scientific world. And sounds like that's you. And guess what? I'm going to be here today, I'm going to come back tomorrow, and I'll be here on Friday. So we get to attend session 3 days in a row. Alright? So we are going to read a text about matter. I know that we're studying matter in science and have plenty of knowledge about matter. And we're going to continue to build that knowledge today. But before we do that, I want to talk a little bit about the materials that you have on your laps. I'm the sort of teacher that gets a little distracted when people are fiddling with other materials. So your job is to pay very close attention to me and to what your classmates are saying, and to not be distracted by the notebooks and the other materials that you have on your lap. Can you do that for me? Okay. I'm going to pass out this text, and your job is just to browse the text, take a look at it, and see what you notice while I'm passing it out to your other classmates, okay? So you can, don't write on it, but you can take a look at it.
Mark, could you scoot up now?
The pages are numbered on this text, so it's hard to know which is the front and which is the back, but this is the front, right here where it says states of matter. That's where we are going to start reading today. So right now I need you as a reader to have states of matter on your notebooks. And your finger on states of matter, right here on the top heading, states of matter. Looks like I'm waiting for no Rocketeers. That was in the right spot. So our job as readers today is to think about a couple of things. First, we are going to think about what is this text about? So studying matter really helps us get better at understanding the world that we live in, and we're going to learn about that a little bit more today. Something that really good readers do is they're able to say what the text is about in their own words. And so we are going to practice that today. The second thing we are going to work on is thinking about why the author wrote this story, this text. What is the purpose? What is the author's purpose in writing this specific text? And then the final thing we're going to think about is, how is this text structured? And we'll talk about that. Sometimes, Rocketeers, I'm waiting for you. Sometimes, knowing and thinking about how the text is structured helps us as readers. So if we know that the text is going to tell us all sorts of details and careful descriptions, we are going to have to read very carefully and pay attention to those descriptions. If it's going to be a comparison between two things, we're going to have to understand how are those two things alike? How are those two things different? And these are the three things we're going to track on as we learn more about matter. So, I'm going to be the reader today, and you are going to be the secondary reader. So, I'm the primary reader, you're the secondary reader, which means as I'm reading, your job is to follow along in the text. And I'll know that you're doing that because I'll see that your eyes are tracking with the text. As we read, I'm going to stop and ask you questions, and we'll have a discussion about what's happening in the text. You might even have the opportunity to draw some pictures about what the author's telling us. Because we know that readers make pictures in their head, to make clear pictures in their head of what's going on in the text. I know that you probably do that as readers. And so we'll get a chance to show what that picture in our head looks like, and we'll put that on the board. Okay? Let's get started. We're going to put our finger on states of matter right there at the top. Show me that you're ready to start, but we're going to take the heading, states of matter. Everything you see is made of matter. Matter comes in three basic states: solid, liquid, and gas. While most of the things we touch every day are solids, the majority of the earth is covered in a liquid, water. Did you know that 3/4 of the earth is covered in water? As we study matter, it is important to remember that everything on Earth is made up of microscopic particles, molecules, ions, or atoms. The speed and density of these particles determine whether the object is a solid, liquid, or gas. Solids, liquids, and gases have unique properties. Let's investigate each. Let's stop there, Rocketeers. This question, what is this text about, is something we're asking ourselves all the time as readers. So let's pause after these first two paragraphs and think about, what is this text about so far? Turn and talk with the person next to you about what you think this text is about so far. It's really hard to get the text if you do that. Sorry, I know that's hard. It's pretty neat. So if you just said, this is not states of matter, that would be as a reader, where does somebody go to get just to get the main idea of what the question is about? Yeah, what's this word? So how could you put that into your own words? Why don't you tell us about that together? How could you put that idea into your own words?
How did you know that? Other than by looking at the text, what are the tools besides just your words and first paragraphs to support it? How else do you know that this is about solids? How else do you know what else in the text that this is about solids and liquids? So the text in the first two paragraphs, where else in the text do you see evidence that this is what? Because I bet I can get the same answer without even reading it. That is starting first. Skim this. Which word did you read first? Exactly. So you're heading
That is a great Rocketeers, let's come back together. I heard some great thinking on the rug. I also heard some people who were a little bit stuck. So I think it's good for us to come back together and talk about this idea. So we have these first two paragraphs, and it would be really easy to say that the first two paragraphs are about states of matter, because that's the heading. But that's too general. Who has a more specific answer for what is the main idea of the first two paragraphs? What are these first two paragraphs about? Let's do a complete sentence. The main idea. That is a fantastic way of saying that. Can you restate what you said? Would you like him to repeat it? Okay, so you need to track on him so you can hear what he's saying. Go ahead. He is made of. What did he just say? The main idea. My first two paragraphs. Everything is made of. Did any group, any pair have a different idea or have an elaborated idea? An elaborated idea is an expanded idea. It expands on this thinking.
As soon as you get your worksheet, you may go back to your desk. If you were at because I can see everybody's
Okay, so this is an elaboration on the idea that Josue shared with us. So he said everything in the world, everything that we see in the world is made of matter. And the elaboration is that everything that we see is either solid, fantastic. So those two ideas really do bring together the core ideas in this first paragraph. Let's keep reading. I think the author is going to give us a chance to develop some more elaborate understandings of solid systems and gases. Put your finger on the word solid, beginning of the third paragraph. I'm waiting for some Rocketeers to put their finger on solid so I know they're ready to read this with me. Fantastic. Remember, I'm the primary reader, and you are the secondary reader. A solid is anything that holds a particular size and shape. A block of wood, a stone, and a piece of plastic are all examples of solids. The particles in the solids are tightly packed and don't make many movements. There is not much free space in between the particles, so there's very little room for the particles to move. Solids are often described as dense and rigid. So, in this paragraph, the author is giving us a description of what a solid looks like. Did anybody make a picture in their head of what a solid looks like in that paragraph? So let's reread that paragraph, and I'd like you to make a picture in your head of what you think a solid looks like as I'm reading. All right? I'm going to read that paragraph again. Solid. A solid is anything that holds a particular size and shape. A block of wood, a stone, and a piece of plastic are all examples of solids. The particles is another way to say tiny parts. The particles in a solid are tightly packed and don't make many movements. There's not much free space in between the particles, so there's very little room for the particles to move. Solids are often described as dense and rigid. So, the reason I had you bring your pencils is because I wanted you to draw right here on the text what do you think the particles in a solid look like. So you might draw a circle. Right? And then inside this circle, I want you to think about what the author's describing. How are the particles in a solid, let me label this. How are the particles in a solid organized? Is the author saying that they're particles that flow around like that? No, it's your turn. You draw a circle and draw what you think the particles in a solid look like. Using the information that the author gives us. You can draw it right next to the paragraph that says solid. Do you have a pencil? Did you not find one in the pocket? Oh, I took it. Have they ready? Okay. I really want to see your video.
Fernando R and Fernando L +2. I love how you guys are working really quietly and concentrating on words.
Rocketeers, 3, 2, 1, track me. So I asked Pamela to come share her representation of what the particles in a solid might look like. And Pamela did a nice job up here. So because we don't want to run out of time, Pamela didn't fill in the whole circle. But Pamela's drawing has the particles really tightly packed. Why? Why did she just draw the particles this way? Nice and up. That doesn't answer the question. The question is why did she draw them really close together? What is it about the particles in a solid? The particles in a solid are really close together. What words does the author use to describe the particles in a solid? Yeah, the author says that the particles in a solid are tightly packed. So if Pamela chose to draw the solid particles like this, that wouldn't represent the ideas in the text, because this is not exactly tightly packed. All right, let's keep reading. Let's read on to read about liquids. I want you to do the same work that I asked you to do for solids. For liquids, I want you to think, what does the representation look like? What is the author describing? Put your finger on the title, on the heading liquid. Put your finger on the heading liquid. You're the secondary reader while I'm the primary reader. A liquid is anything that has size or volume, but does not have a shape. Liquids must be contained in something such as a cup, bottle, or container in order to have a shape. Water and milk are examples of liquids. When you pour water into a glass, it takes the shape of the glass. If you spill the glass of water on the floor, it will spread quickly as it takes the shape of the floor. Liquid particles are not as close together as particles in a solid, and move around and pass each other more freely. They have no regular shape or arrangement and move freely. So let's do the same work. And this time, instead of a circle, let's actually draw a container. I'll draw just a little cup here with a measuring cup with a skinny picture. And let's just pretend that there's something in our cup. What do the particles look like here? Draw a representation on your paper for what you think the particles look like in a liquid, based on what the author tells us. Rocketeers, America and I just had a really interesting conversation that I want to share with you. So she said that this is filled with nothing, right? That was your assertion, that this is filled with nothing. I said, well, you've drawn something on your paper. You've drawn this, right? Is that what you have on your paper? And she said, well, they move around. I said, well, what moves around? She said, the liquidy stuff moves around. So the question is, What about a liquid? What about the particles in a liquid makes it so that they can move around? Erica? Make some loud so that your classmates are reciting close. The particles are not typed. What language does the author use in the text to describe the particles? What does the author say? It's a rather simple sentence in the section on liquid. What's the evidence from the text? Go ahead. What does it say before that, though? Liquid particles. Okay, let's stop there. They're not as close together as particles in a solid. So, does this representation match your thinking about the particles in a liquid? Doesn't match your thinking? It does. Rocketeers, we're going to read the last section on gas. Put your finger on gas. Gases are hard to identify because they have no color or shape. The air you breathe to stay alive is a gas. So, what's the most common state of matter in this room? Based on what we just read. Muhammad? Which is what? Let's keep reading. Air is actually a mixture of gases, mostly nitrogen and oxygen. Gases have no shape or size. Particles in a gas move freely at high speeds. There is a lot of free space in between the particles, and they take the shape of any container. So, let's do our last representation based on what the author's telling us about particles in a gas. Let's say we have a balloon filled with helium. Helium is a gas. What do the particles look like in a helium balloon? Draw that on your paper based on what the authors told us. Gases are hard to identify because they have no color or shape. There's lots of free space between the particles. Pardon? Tomorrow. You're more than welcome to vouch for it. Some of you are noticing that there's representations on the second half of the text that maybe look like the representations we've been working on. That's okay. As scientists, it's helpful to do some of this pre-thinking to help you develop our understanding. So Rocketeers, who can describe in words what the particles should look like in this gas balloon? This helium balloon? New hand. Okay, let's put that in complete sentence. So these are very far apart. So let's put that idea into a complete sentence. The particles in a helium balloon are very far apart. Do you want to add to that? They move at, how could you say that in different words, rather than round and round? How could you say that using scientific language? The particles in a balloon move. The scientists might say, oh, it seems like you have an idea, Mohammed.
Rand, if your computer is not working, it's your job to be reading a book right now.
It's fantastic. Did you hear his thinking? I think you might have missed it because you're talking to your classmates. There's some great thinking over here. Can you restate that so that your classmates can hear? And you used a really nice complete sentence. This was fantastic. Particles go at very high speed. So scientists worry about how fast particles move. Rocketeers, we have one last job before we put our text away for the day. Our job right now is to think about making a main idea statement. So one way that I think about main idea statements is I think about taking a bird's eye view on the text. A bird's eye view. What's a bird's eye view? I don't know how a bird makes up a word. Any new hands? What a bird's eye view might be? I see some people, I can see their minds working. What are you thinking? So a bird's eye view is a very high view. It gives us a chance to think about if a bird was looking at this text just from the top, what's the big idea this text is about? So turn and talk to the person that you had talked to before. Think about what is this text about? What is the main idea?
So these should be touching, right, Rocketeers?
Main idea.
Good.
This text.
And here's some nice complete sentences. The main idea of this text is. Tell us about all three states. If you just say one, it just like captures the main idea. Okay, Rocketeers, let's come back together. We have 1 minute, so we need to work efficiently. Which means we all need to be tracking on me and then tracking on our classmates as we listen and try to construct a main idea statement. What is this text about? Who would like to offer an idea what this text is about?
Chris.
Okay, so the classmate has offered the idea that the author is teaching us about the three states of matter. Does anyone want to elaborate on that idea or agree or disagree with that idea? Mohammed? Yes, it did. We should be tracking Mohammed.